Welcome. The Passive Sampling Technology Update team is proud to present an overview of the fossil fuel sampler, also known as CO2 trap technology. This quick video will provide a high-level overview of the device, as well as instructions on how to use, deploy, and retrieve the device. For more information on this and other passive sampling technologies, please visit the Passive Sampling Technology Update Guidance document. The Fossil Fuel Sampler, or CO2 trap, is an accumulation-type passive sampler. CO2 traps are used to measure carbon dioxide in soil gas. The device are at-grade passive samplers that measure time-integrated carbon dioxide fluxes through the surface at petroleum-contaminated sites. CO2 traps are patented canisters that contain a strongly alkaline, solid-state sorbent material, which converts the CO2 passing through the material into stable carbonates that are retained in the trap. The total carbon dioxide flux is captured from natural soil organic matter, which is expressed as modern carbon, and from light non-aqueous phase liquid, which is expressed as fossil fuel carbon. The top of the trap is open to the atmosphere to allow pressure equilibrium through the trap. The top sorbent element intercepts atmospheric CO2 to prevent sorption of atmospheric CO2 in the bottom element. The bottom element captures CO2 released from the soil, also known as soil gas efflux, resulting in a time-integrated estimate of CO2 flux normalized to the cross-sectional area of the trap. The bottom sorbent layer in each fossil fuel trap undergoes quantitative radiocarbon or carbon-14 analysis in order to determine the amount of fossil fuel-derived carbon in the sample. The CO2 flux rates are then used to determine the rate of naturally occurring biodegradation of light non-aqueous phase liquid, or natural source zone depletion rates. The CO2 trap includes the following parts. Upper and lower sorbent element consist of granular sorbent media held by stainless steel screens and a PVC tubular frame. Steel wool packing reduces dead space between the two trap elements. The PVC CO2 trap sampling container body connects to 4-inch diameter in-ground PVC CO2 trap sampling receiver. Rubber O-rings connector with 2 adjustable hose clamps, 3 eye bolts and stakes to affix to the ground, and a rain cover. The receiver installation consists of the following steps. Tighten the eye bolts through the U-nuts on the sampler. Place the beveled side of the 4-inch receiver vertically on the ground. Using a rubber mallet, hammer the receiver 2 inches into the ground. Keep the receiver vertical. If the soil is too hard for the receiver to penetrate, use a knife to cut a ring in the soil. Hammer the stakes through the eye screws on a 45-degree angle away from the sampler. The sampling container deployment consists of the following steps. Remove the top and bottom caps from the trap. Screw the rain cover on the top side of the trap. Slide the trap and rubber connector into the installed receiver pipe. Tighten the top and bottom clamps of the connector. Here are some considerations when deploying CO2 traps. Always keep the traps upright. Do not deploy the samplers after rain or watering, and avoid saturated soils and standing water. The device is moisture-resistant but not waterproof. Keep the traps covered and away from ambient air until deployed. The standard deployment time for fossil fuel traps is 14 days. Although this time frame can be modified within a range of 5 to 28 days without further modification of the traps. After the equilibration times, return to the site and remove the rain cover, loosen the clamps, and pull the sampling container, ensuring the device is kept upright. Before placing the caps back, remove insects and organic matter that may have accumulated. Place the capped sampling container in a cooler. Remove the provided travel blank from the sealed bag and place it in the cooler with the CO2 traps. Do not use ice to preserve the samplers. Some of the advantages of the CO2 trap include: the samplers do not require power, so they can be deployed in remote locations. They are easy to use without specialized training. They can produce time-integrated average flux measurements, accounting for diurnal and daily fluctuations. The carbon-14 analysis used to differentiate fossil fuel-generated CO2 from modern CO2 interference, providing a location-specific background. Some of the limitations include: CO2 traps cannot be used in areas with impermeable surface cover that limits atmospheric soil gas exchange, for example, asphalt, concrete, or geomembrane liners. Saturated soil can hinder CO2 mobility to the surface, thus biasing the results low. Their use may not be valid at sites where carbon-14 chemicals have been used or near sites in the vicinity of nuclear reactors or waste. Samplers must be returned to the manufacturer for laboratory analysis. Remember, you can learn more about the fossil fuel sampler and others in the ITRC Passive Sampling Update online guidance document.